So this is part 2 of how to run the ANOVA, follows straight on from part 1. So in part 1, we looked at how to pull apart these hypotheses. The first two compare men and women at different levels of license group, and the second lot compares license level in the men first, and then hypothesis 4 and 5 looking at the women. And both lots we saw before predict that we will get an interaction, and when we did the analysis we found that there was a gender by license group interaction. So the story continues. As soon as we get an interaction, we know that we have to pull it apart to see what's going on. Interaction is the effect of one IV is different at different levels of the other IV. So the way we analyse it, it's called simple effects. We look at the effect of one IV at each level of the other IV because it somehow changes. And as soon as we have described how it changes, we have accounted for the interaction. So that's the name of the game. Why did we get this interaction? Can we explain it? Simple effects is the basic way to do it. So simple effect, the effect of an IV at each level of the other IV. So we could look at the effect of gender, one of our IVs, at one particular level of license group, so the P1s. Or we could look at the effect of license group just at the men. So we're looking at the effect of one IV, differences amongst the levels of that IV at a particular level of the other IV. So we've got two options when we've got two IVs. First, in this example, we can look at the simple effect of gender. Effect of gender, is there a difference between men and women? That's the effect of gender. So we compare men and women at each level of license group. So simple effect of gender at each level of license group. Or alternatively, we could look at the simple effect of license at each level of gender. So we look at differences amongst P1, P2 and open for the men, and then we look P1, P2 and open, compare those levels, but only looking at the women. Okay, so those are the two options for how to attack it. It depends on your hypotheses, which one you will need. We saw in the previous slide that we have hypotheses that ask us to compare genders, and we have hypotheses that ask us to compare license groups, so we're going to have to do both ways of comparing. So let's do that. Okay, and the way that we're going to go about doing that is using syntax. Okay, so here's the syntax that we generated earlier. We ran this already in the first video. And what I'm going to do here is type compare. Now, our first pair of hypotheses wanted us to compare men and women at each level of license. So we're going to do that. But we also want to compare the other way around. So what I've done there, I've just doubled that line. You can see there I've got EM marginal means, blah, blah, blah. Two lines currently identical. Well, what I'm going to do is put the other IV, copy that and paste it there. Now notice I've got, now this has to be typed against the interaction term. So license by gender. I type compare gender. And because it's against the interaction term, it's going to compare genders at each level of the license variable. The next line down, it says compare license. It will compare license conditions, license groups at each level of gender, which is exactly what I want it to do. So that's how you set up the syntax. So you just type in this compare, name a variable against the interaction term. If you need to do it two different ways, you just repeat the line. So then you highlight all of that and hit the play button. Now, all of this output is exactly what we produced earlier with the just running the plain ANOVA. But if you look at the navigation screen down the side, we've got here at 1, this is the effective license. I'll just open that up a little bit so you can kind of see it. Okay, 1, P1, P2 open groups. That's the main effective license. 2 just says gender. That's the main effective gender. 3, P1, P2 open groups by gender. This is the interaction. And then 4, same thing again, because we asked it to do the interaction a second time. And what we really want are these pairwise comparisons. That's the critical thing that typing the compare command produces. It produces pairwise comparisons. Okay. So as you scroll down through the output, again, we've got Levine's, again here, the interaction. This is exactly the same output as we saw in the first video. But this time as we scroll down, remember before we looked at the interaction and then straight away we had plots. This time we have extra output. We have these pairwise comparisons. And this is the critical stuff that allows you to do simple effects. So this table here that I've just highlighted, this is the pairwise comparisons table. That's important, and so is the next table down. They just bounced around a bit. I'm looking at this pairwise comparisons table and this univariate tests table. Okay. Now, the univariate tests, you start there because that's the ANOVA. It's going to give you permission to do pairwise comparisons. Remember, basic ANOVA approach, you have to see a significant difference among the groups and then find out where that difference occurs by comparing each level with each other level. So first we look at the univariate test to see, is there an effect? And what we see is for P1, there is no effect of gender. For P2, close but not quite. P is 0.062. And for the open group, we do see a significant effect of gender. Now, if you remember back to our hypotheses, let's see, what was it? Hypothesis 1 was that men and women would differ in risky behaviour in the open condition. Men would be riskier. Okay. Now we have an effect of gender in the open group. We'll have to consult the means to see who's riskier. I know who my money's on. The other hypothesis, hypothesis 2, I think it was that there would be no effect of gender at P1, and we get no significant difference for P1. So it looks like our hypotheses might be supported. Now, you notice the p-values here in this table, 0.113, 0.062, 0.000, are also up in this table, 0.113, twice, 0.062, 0.000. You don't need this pairwise comparison table when you are looking at the effect of an IV that's only got 2 levels. The ANOVA says there is a difference. Next question is, where is that difference? If there's only 2 levels, there's only one place it can be between those 2 levels. So we don't need to do any further investigation when there's only an IV of 2 levels, as is the case here for gender. So we can just use the univariate tests to address our hypotheses for those first 2. Hypothesis 3 said that for men, there would be no effect of license group on risky behaviour. So we can't see that here. Here we see the difference between men and women. We cannot see the men on their own and look at the effect of license group. That's why we had to do the compare command twice. We need to compare license groups at each level of gender because we want to see, is there an effective license group for the men? And then for hypotheses 4 and 5, we also want to see that there's an effect of license group in the women. So we need to do it the other way. So we scroll down further. Here is where we typed in the second command and we said compare license group. And that's it. That when we type in compare license against the interaction term, we get compare license levels at each level of the other variable in the interaction, in this case gender. So here is comparison of, I'll scroll down a little further so we get the pairwise comparisons and the univariate test. And again, we'll start with the univariate test. We'll do this the right way. So first, for females, we have a significant effect. So there is a difference amongst license levels for the women. So we have permission now to go back and look at the pairwise comparisons table to see where the difference occurs. Now, in this particular case, we can answer hypothesis 4 with this output. We cannot answer hypothesis 5 with this output. Hypothesis 4 said there will be no difference in the women between P2 and open license. So once they get off their P1s, women will have reduced their risk and they don't reduce any further after that. P2 and open are equally risky. Okay. Now, if you look at this pairwise comparisons table, just looking at the females, every time in this thing, it compares level I with level J. So who's level I, who's level J varies as you work down the table, but it's always comparing the group listed in this column with the group listed in this column. So the first one, P1, is listed in the left column. So that's being compared first with P2 green and then with open. This is P1 versus P2, P1 versus open. Okay, and you can see here that both of those pairwise comparisons are significant. P1 is different to P2. P is 0.009, and P1 compared to open, that too is significant. The difference there is P is less than 0.001. But that wasn't our hypothesis. Our hypothesis was about P2 versus open. And if we look here, P2 compared to P1, we've already had that. We get the same p-value, 0.009, there and there. But what we want is P2 against open, and for that, we get P is 0.216. So P2 is not significantly different to open in the women, which supports our hypothesis. Hypothesis 5 said P1 would be different to all of the other women. Now we can compare P1 to the P2 and we can compare P1 to the open, but we can't compare, in this technique, P1 to the combination of P2 and open. For that we'll need L matrix, for that you'll need to watch another video. So that's the women. Okay, if we look at the men, we might be tempted to start looking at these pairwise comparisons. But first, we have to check, is there a difference amongst the license groups for the men? And the answer is no. P-value is 0.055. There is no significant difference amongst license groups for men. So the ANOVA does not give us permission to start comparing P1 with P2, P1 with P3, P2 with P3. We can't do that because the overall ANOVA, the omnibus test, says there is no significant difference anywhere amongst these groups. So don't go thinking you can find one. Okay, so that prevents us from going back to this table. Now, one other thing to say, in terms of reporting this pairwise comparisons table, when you have more than two groups. When you only had two groups before, and we had an effect of, I'll scroll back up to that, when we saw an effect of gender for the open license condition, we could report this F statistic. There's the F, there's the degrees of freedom, there's its p-value, partial eta squared, everything we need to report an F statistic to say there is an effect of gender in the open group And then we would simply go back to the means, which are fortunately just up here. In the open group, there's the men, 3.39. There's the women, 1.49. Men are riskier than women on open licenses. The F statistic tells us it's significant. The means tell us the direction. Men scoring higher than women. Men are riskier. Okay, so we've got an F statistic when there's 2 levels. When there's 3, scrolling back down again to that comparison of license group, the F tells us there's a difference somewhere. If I want to now say my P2 group is significantly different to my open group, I've got mean difference, standard error, significance. This is comparing one group with another group. That should be a t-test. I don't have a t-value, but I can get one. I'm going to show you how. I'm going to do it here in SPSS so that you can see it. I'm going to add in some extra text down there and show you what we do. So P2 versus open, my mean difference is 0.494. I go 0.494 and I divide that by the standard error alongside it, which is 0.398. Okay, so I want to find out what that equals. Here's a handy calculator. We've got 0.494 divided by 0.398 equals 1.24. And that is our T statistic. I got thrown there a little bit. You might have noticed a little pause. Okay, so that equals 1.24. Okay. I had forgotten that we were looking that it was a non-significant T, because I thought a T of 1.24 is not significant, nor should it be. P-value 0.216. So I can write that T. Now I need degrees of freedom. Degrees of freedom come from the ANOVA test down here. The error degrees of freedom is the correct one. So my T is 153 equals 1.24. P equals 0.216. Not significant. Okay, so that's how you can get a T statistic if you want one. You could just report the p-value. Really, it's all you need. But if you want a T statistic, that's how you calculate it. It's the mean difference divided by the standard error will give you the T. And you grab the degrees of freedom from down here, the error term in the univariate tests. So hopefully, amongst all of that, you've gotten straight how to interpret that pairwise comparisons table. So let's see whether that addresses our hypotheses. Hypothesis 1, women with more than 3 years, so open licenses, be less risky than men, and that's what we got. Men were more risky, it was 3.3 something to 1 point something or other. We also found men and women with less than 1 year, there was no significant difference. Okay, and hypothesis 3, it says levels of driving experience would have no influence on reports of moderately risky driving behaviour in men, and we got a non-significant effect of license group for the men. P was 0.055. Now we actually did, so we've taken care of all three of those. We actually did address hypothesis 4, but the one we really haven't addressed is hypothesis 5. But we're going to do those two hypotheses with the L matrix in another video. That'll be part 3.